myself Dr. Susmitha. I am working as Assistant Professor in Chemistry in Institute of Aeronautical Engineering. Today, we are going to discuss about municipal water treatment. This municipal water treatment, it is a part of water technology. By end of this topic, you will be able to understand and identify the characteristic properties of potable water. Means you will be able to know what is potable water and what are the characteristic properties of potable water. Along with this, we will be studying and discussing the steps that are involved in treatment of water for municipal supply, that is for domestic uses. Now, what is potable water? Potable water, it is a water that is suitable for human consumption. If the water is suitable for human consumption, then it should have some characteristic properties. If the water meets those requirements, then only that water is called the potable water. So potable water, it is nothing but the water that is suitable for human consumption is called potable water. If we drink water that doesn't meet these requirements or characteristic properties of potable water, then there is possibility that we may fall sick and we may suffer diseases which are caused because of presence of bacteria and all. We will be suffering with diseases because of those. So if we drink potable water, then these sufferings or the falling sick can be avoided. So, talking about the characteristic properties of potable water, the water, it must be free from dissolved gases like hydrogen sulfide, ammonia, carbon dioxide. All these must not be present in water. And also, the water must be clear without any odor. Means it must be clear and odorless, without any bad smell. And also, the water, it must be free from the pathogenic bacteria that is causing, pathogenic bacteria means harmful causing bacteria which are harmful for our health. So, water, it must be free from the dissolved gases, it must be clear and odorless, and it must be free from the pathogenic bacteria. Along with that, the water must be free from the heavy metals like lead, arsenic, manganese. So many heavy metals are there, and the water, it should be free from these heavy metals. Otherwise, it is not considered as a potable water. Now, there are some limitations or some values where the potable water must have or that should be maintained in the water. That is, the pH of the potable water, it must always be between 7 to 8. The pH, it must be maintained between 7 to 8. Always the water, it is neutral in nature. Neutral in the sense, the pH, it must be 7. If the water is in between 7 to, pH of the water is in between 7 to 8, then that water is considered as a potable water. Now, talking about the total dissolved solids. The total dissolved solids that are present in water should not exceed 500 ppm. And the turbidity of water, it should not exceed 25 or 50 ppm. 25 to 50 ppm is the limit. And total hardness of water means the optimum hardness of water, it must be in between 125 ppm. So these are the values where the potable water must be maintained. That is, the water, it should be clear, clean, clear and odorless. It must be free from the pathogenic bacteria, and optimum hardness of water must be 125 ppm. pH must be between 7 to 8. Turbidity of water should not exceed 25 ppm. And maximum concentration of the total dissolved solids, that is TDS. It should not exceed 500 ppm, and the water, it must be free from the heavy metals. So these are the characteristic properties of potable water. If the water meets all these requirements, then the water is considered as a potable water. Now, let us see how the water is treated for municipal water supply. Municipalities, the municipal water, it is supplied to our household purposes for domestic use, and it is also used for drinking also. Nowadays, we are using ROs, but in previously and even now also in some of the small cities, they are using this municipal water for drinking purpose and also for the household purposes. These municipal water, it is not supplied as such, means the water as soon as it is collected from the sources of water, it is not supplied to our domestic purposes. First, it is properly treated and they are tested, and then they are sent to our household channels where the water is supplied from the overhead tanks. So there are several steps where the water undergoes treatment. So these steps we will be studying in this treatment of water, that is a municipal water treatment. So municipal water treatment, it is a process of removing all those substances, whether they are biological, means microorganisms, chemicals in the sense if any impurities or just like iron and manganese, just I told, no, these heavy metals, those must be removed. And even physical impurities in the sense some colloidal particles, suspended particles, and even if sand, not sand, like floating particles like wood, leaves, even they also must be removed. So if the water, if it is free from the physical, chemical and biological impurities, then that water is supplied for municipal, that water is called municipal water, and that water is supplied for our household purposes. The various steps where the water is supplied for the municipal treatment are, first comes screening. The first step is the water, it is collected from the sources like rivers, lakes. They are the sources of water, natural sources of water. First, the water is collected from the source. That is, let us take up like the water is collected from a river. Several tons of water, it will be collected from the river. Then it is subjected to a series of processes where the first step is screening. Next one is aeration. Next step is sedimentation. Next one is a coagulation with sedimentation. Next comes a filtration process. Next, final step will be the disinfection process. Once the disinfection is completed, then it is tested whether it meets all the characteristic properties of potable water or not. Once the water meets all the requirements like pH, TDS, turbidity, all of them are tested. Once the water meets the requirement, then it is supplied for our domestic purposes. Means that it is supplied for our households. Now let us see each step in detail. The first step is a screening. In screening, we will be using the screeners. Screeners, they are nothing but they are they are very large plates with a large number of holes. Means perforated holes will be present. You can see in this picture, this is a screener, and this is also a type of screener. Means it is having so many holes. These are the holes. So the screening, the water is allowed to pass through the screeners. These are nothing but these are screeners. When the water is allowed to pass through these screeners, the floating particles like the wood, leaves, covers, super covers, or whatever the floating particles or the larger sized particles, they can be removed. Means they will be stopped at the front part of the screener, and the remaining water will be flowing through them because holes are present. The water will be flowing through these holes. See in the picture also you can see here there is some cover, and these are the large particles, no, which are large in size. Means wood, leaves, all of them can be removed with the help of a screen. The next step is a aeration step. In this aeration step, the water, it is bubbled with the air. Here you can see here large quantities of water, it is bubbled with the air. When the water is bubbled with air, the dissolved gases like hydrogen sulfide, carbon dioxide, I told, no, the water, it may contain some dissolved gases. These dissolved gases are replaced with the air. When these dissolved gases are replaced with the air, obviously there will be an increase in the oxygen content. Air, it is rich in oxygen. So the water, when it is bubbled with air, there will be an increase in the level of the oxygen, and the undesirable gases like hydrogen sulfide, ammonia, they can be replaced with the air. One more advantage of this bubbling the water with air is, that is the aeration step, is if metals like heavy metals like manganese or iron, these are the heavy metals that may be possibility that water may contain these heavy metals. If at all manganese is present, when it is bubbled with air, this manganese, they will be converted into hydroxides, that is a manganese hydroxide formation may take place. In this way, some of the heavy metals can also be eliminated with this aeration step. So screening, the floating particles can be removed, and with aeration, the dissolved gases like hydrogen sulfide, ammonia can be removed along with increase in the water level, along with increase in the oxygen level. Next comes the sedimentation. Sedimentation, it is nothing but it is a process where the water, it is allowed to stand undisturbed for 2 to 8 hours. Depending on the quantity of water, the time is selected. But in sedimentation, the water, it is allowed to pass through a hollow tank, through a very large tank, and it is allowed to stay undisturbed for several hours. Through this sedimentation step, the larger particles, means the heavy particles, which will be able to settle down because of the gravity of the earth, that those particles can be removed. In sedimentation, the water is allowed to stay undisturbed for several hours. So the heavy particles, they will settle down at the bottom of the tank. Once these particles will settle down at the bottom of the tank, the water is decanted, and what all will be settled at the bottom of the tank, those will be discarded. So the water which is remaining at the upper portion of the tank, that is collected for further treatment. With this sedimentation, about 70 to 75% of the suspended matter can be removed. Well, only 70 to 75% can be removed. Still suspended matter, it will be present in water. To remove the suspended and colloidal particles, it is subjected to coagulation. Next comes a coagulation with sedimentation. In sedimentation, previously the third step is sedimentation. In sedimentation step, we have removed the suspended particles. But colloidal particles, it is very difficult to remove by this sedimentation step. So now, the water which is collected after sedimentation process, it is added with some coagulants like alum, aluminium sulfate, alum, that is K2SO4, Al2SO4, 24H2O. This is the chemical formula of the alum. So the water, these are called the coagulants, alum, sodium aluminate. These are called the coagulants, and these coagulants are added to water. When these coagulants are added to water, there will be formation of some gelatinous substances called phloem. These gelatinous substances will entrap the colloidal particles that are present in water. In this way, the colloidal particles are removed. And once these gelatinous substances are formed, the water, it is again subjected to sedimentation, means the water, it is allowed to stand undisturbed for few hours. All the gelatinous substances which entrap this colloidal and suspended particles will settle at the bottom of the tank. Again, the water can be decanted, and whatever is settled at the bottom of the tank, that one, it is discarded because it contains all the impurities which is not desirable. So that one, it will be discarded, and whatever the water left over, it is collected into another tank. So, in order to increase the activity of the coagulants, we will be adding the coagulant aids. Coagulant aids means they will increase, means they will speed up the process, they will increase the activity of the coagulants. That is, the gelatinous substances which are formed because of the coagulants, that formation of the gelatinous substances will take place quickly. And the coagulant aids are lime, fuller's earth, polyelectrolytes. These are some of the examples of the coagulant aids which will increase the process of coagulation, so that time can be saved. Once the coagulants are added, gelatinous substances will be formed which entrap the colloidal particles and suspended particles, and then it is subjected to sedimentation. So this step, it is termed as a coagulation with sedimentation. Okay, so sedimentation step, it is also followed after adding coagulants. Next step is a filtration process. So in this filtration process, we will be using equipments called the sand filters. So these sand filters are of two types, namely the slow sand filters and rapid sand filters. Now just let us see how the construction of these sand filters will take place. This is an example of the sand filter. This is a slow sand filter. See, this sand filter contains several layers, where the bottom layer, it is the quartz gravel. Gravel, you know, the kind of clinkers or stones, they will be of this size. Quartz in the sense comparatively big size. Okay, the bottom layer, it is made up of quartz gravel. Above this quartz gravel, fine gravel will be present. These are also stones, but they are of smaller in size. Just like in construction, if you are constructing a building, you will be seeing some chips kind of stones, and some stones which are bigger in size. That bigger size stones are called the quartz gravel, and these chips, that is a smaller size stones, are called the fine gravel. These are of smaller size. Okay, this is quartz gravel and this is fine gravel. Above this fine gravel, it is filled with a layer of quartz sand. This is a quartz sand. Sand, you know, the single, if I take a single sand particle, the quartz sand, it will be very smaller in size, but above this quartz sand, fine sand is also filled. See, if you just see, the size of the particles. Here, quartz gravel, fine gravel, quartz sand, fine sand. The difference is quartz sand, it will be a bit larger in size, and fine sand, it will be very smaller in size. Okay, these are the 4 layers of the sand filters, which plays very important role in removal of the colloidal and suspended particles. Okay, now these sand filters with the sedimentation and coagulation with sedimentation step, I already told, we can remove the colloidal and suspended particles. So it's not necessary that 100% colloidal and suspended particles are removed by these 2 steps. There is possibility that these particles, some of these particles may be left over in water. If at all, if these particles are left over in water, those particles or those impurities, that is the colloidal and suspended impurities, these can be removed by this filtration step. Means the water, it is allowed to pass through these sand filters. When the water is allowed to pass through these sand filters, whatever the colloidal or suspended particles which are left over in water, they will be entrapped in this fine sand. This fine sand itself, it will filter off these particles or impurities, and by the time the water percolates all these through these 4 layers, the pure water can be obtained. Now, after some time, the rate of filtration, it may decrease because the fine sand, it will get exhausted with, means the fine sand, it is completely filled with this colloidal and suspended particles. So, in order to increase the rate of filtration, this fine sand layer, that is the topmost layer, it is scrapped. It is scrapped off, means this fine sand layer, it is removed and it is replaced with a fresh fine sand. In this way, the rate of filtration, it can be maintained as such. So, in this filtration step, we will be using sand filters where there are 4 layers: quartz gravel, fine gravel, quartz sand and fine sand. When the water is allowed to pass through this sand filter, the colloidal and suspended particles which are left over from in the previous step, which are not filtered or which are not removed in the previous step, those impurities can be removed in this filtration step. As already I told, this sand filters, they are of 2 types. namely the slow sand filters and rapid sand filters. This is an example of the slow sand filter. While talking about the rapid sand filters, we will be supplying some pressure. A tube is attached to this lower part of the sand filter, and some pressure is supplied to this sand filter. Because of this pressure, the whatever water enters into it, it will percolate through these layers of the sand filters very quickly. Because of that pressure, the gravitational pull, and because of that pressure, the water, it can be percolated, or it will move very fastly through these filters. This is all about the filtration process. Rapid sand filters and slow sand filters. The name itself indicates slow sand filters means because external support is not there, so the water, it will percolate slowly. And rapid sand filters, because external support is there, some pressure is supplied to the sand filters, and water, because of that pressure, it will filter, means it will percolate through all the layers of the sand very quickly. Now this, the advantage of this filtration step is, already I told, suspended and colloidal particles can be removed. Along with that, there is possibility that if some percentage of bacteria, they can be killed. Not all bacteria, but small percentage of bacteria can be killed by this, or can be removed by this filtration step. The final step in the municipal water treatment is a disinfection. Disinfection. This is a very crucial step and very important step, because this disinfection step, it is nothing but it is a removal of the pathogenic bacteria or harmful bacteria. Pathogenic bacteria, it causes harm for the humans. So if we doesn't remove this pathogenic bacteria and we drink water, then what will happen? Obviously, we will fall sick. So that's why this disinfection step is very important. So disinfection, it can be defined as disinfection. It is nothing but the removal of the harmful pathogenic bacteria from the water. So this disinfection, it can be performed with 3 steps. One is a boiling, the other one is ozone treatment, and the third one is chlorination. Means chlorine is used for the removal of the pathogenic bacteria. Now let us see one by one. The first step is a boiling. So talking about boiling, the water, it is taken in a kettle and it is subjected to boiling for 15 or 20 minutes, depending. It depends. Okay, once the water is when the water is subjected to boiling, the pathogenic bacteria, it cannot withstand higher temperatures, because the water, it will boil at 100 degrees centigrade, and the bacteria, mostly they cannot withstand such high temperatures, so obviously they will die. So it is nothing but removal of the harmful bacteria. So by boiling water, you can remove harmful bacteria. Generally, this boiling method, it is generally used in our houses. Means in our houses, generally in olden days, people used to boil. Even now also people are boiling water to remove bacteria. But this boiling process, it cannot be used for municipal water treatment, because municipal water, it must be supplied in several tons. We cannot boil several tons of water. So this is practically not applicable, or this boiling method, it cannot be used practically for municipal water treatment. Boiling method, definitely it will kill bacteria, and it can be used in our households. Our household drinking, we can boil water and drink. So this is about boiling. And one drawback of this boiling is the taste of water. If we boil water, the taste of water, it will slightly alter. That is another drawback. One drawback is it cannot be used for municipal water treatment. And second drawback is the taste of water, it may alter slightly. So the second method of disinfection is by ozone. Ozone, ozone, it is nothing but O3. In this method, the ozone gas, it is bubbled through water. Ozone being unstable, it will dissociate and results in the formation of nascent oxygen. This is nascent oxygen. So this nascent oxygen, it will act on bacteria and it will kill the bacteria. So here the actual disinfectant, it is not the ozone, it is nascent oxygen. ozone gas, when it is bubbled through water, the nascent oxygen formation will take place, and this nascent oxygen, it will kill the bacteria. Now, we cannot use this ozone for municipal water treatment also, because the ozone, it is very costly, and even transportation, it is an unstable, it is in gas form, it is unstable, so it cannot be used for municipal water treatment because it is very costly. It is not cost effective to treat tons of water, and using ozone, it is not suggestible. Okay, so this ozone method, it can be used in treatment of water for disinfection in pharma industries. Okay, because this is a best method. As I told, boiling, ozone and chlorine, these are the three ways where disinfection process can be performed. But this disinfection, among all these three methods, ozone, it is the best method to perform this disinfection. But as the ozone, it is very costly, we cannot use it for municipal water treatment. But this ozone treatment is used in pharma industries because it must be, we will be using that sterile water. See, if you, some of the medicines of the kids, they will provide an amber colored bottle with a powder. Along with that, there will be some sachets, this size of sachets they will provide. And the doctors, they will ask, just use only the water that is provided in the sachet, because it is a sterile water, it doesn't contain any bacteria, and that water, it is mixed in the powder and it is converted into syrup. That water which is supplied along with that powder, it is called the sterile water, and that sterile water is prepared by ozone treatment only. Okay, so ozone treatment, since it is very effective, it is used in pharmaceutical industries mostly. It is not used for municipal water treatment. So, next step is by chlorination. Boiling, it is done, which is not suitable. Ozone also, it is done, which is also not suitable for municipal water treatment. Now, the third one is a chlorination. Means the chlorine, it is used for treatment of disinfection, means removal of harmful bacteria. Now, this chlorination process, in this we can use three reagents. That is, one reagent is a chlorine gas, the other one is a chloramines, the third one is a bleaching powder, that is CaOCl2. Okay, this chlorination, it can be performed by chlorine gas, chloramines and bleaching powder. Now let us see the series of reactions that will take place when water reacts with these three. When we were asked how the chlorination process is performed, then you have to answer like the chlorination, it can be done by using three reagents like the chlorine gas, chloramines and bleaching powder. First one is a chlorination. Chlorine gas, chlorination by chlorine gas. Now the chlorine gas, it is bubbled through water. When chlorine gas is bubbled through water, there will be formation of hypochlorous acid along with HCl. HCl, it will be a byproduct, but hypochlorous acid, that is HOCl, it is formed, which is a disinfectant and it will kill the actual bacteria. Means this hypochlorous acid, it will act on the cell wall of the bacteria and it will disrupt the cell wall of the bacteria. If cell wall of bacteria is disrupted, obviously the bacteria or the microorganism, it will die. So, when chlorine gas is bubbled through water, hypochlorous acid is formed and this hypochlorous acid will act on the bacteria and it will kill the bacteria. So here hypochlorous acid, it is a disinfectant. Just like how nascent oxygen, it is a disinfectant when ozone is treated, when ozone is used for treatment. Similarly, hypochlorous acid is a disinfectant when chlorine gas is used. And this hypochlorous acid, it is formed as a product when chlorine reacts with water. And this chlorine gas, it is not suggestible because the chlorine, as it is in gaseous form, it is not stable. It cannot be used for municipal water treatment. Okay, next one is the chloramines. Chloramines means these chloramines are formed when chlorine and ammonia are taken in 2:1 ratio, then chloramines are formed. These chloramines, when they come in contact with water, there will be formation of hypochlorous acid along with release of ammonia gas. Obviously, hypochlorous acid formation is there, means it is a disinfectant. So, chloramines also will act, means they will also kill the bacteria by acting on the cell wall of the bacteria. But even these chloramines, they cannot be used as a disinfectant for municipal water treatment. Okay, means they are required in larger quantities. So, it is difficult to manage the treatment process if we use chloramines. Generally, these chloramines are used as disinfectants for swimming pools. Swimming pools, the treatment will be done. Swimming pool water, it is always, it is for maintenance, we will be treating water. So, this water, it is, if we generally use chloramines for treatment of the swimming pools. Water that is present in swimming pools. The third type of reagent that is used in chlorination is bleaching powder. That is CaOCl2. Bleaching powder, it is used for it is a third reagent used for disinfection. So, when this bleaching powder reacts with water, when it reacts with water, calcium hydroxide is formed along with chlorine gas. You know, this chlorine gas on reaction with water, again it will form hypochlorous acid with HCl. Hypochlorous acid being disinfectant, it will kill the bacteria. So, in this way, the bleaching powder acts as a main reagent to kill bacteria by releasing hypochlorous acid. Now, for municipal water treatment, this bleaching powder is mostly preferred because the bleaching powder it is available at cheaper rate, and instability, all those factors will not stay as it is available in a powder form. If it is in gas form, means instability will be there. But bleaching powder, being it is in powder form and it is available at cheaper cost, it is mostly used for municipal water treatment. Okay, once this bleaching powder is added to water, what all the bacteria or harmful microorganisms that are present in bacteria, it will be killed because of the formation of hypochlorous acid. So, if you observe carefully in this chlorination process, hypochlorous acid is the main disinfectant. If it is by chlorine gas, hypochlorous acid is formed. Whether it is in chloramines, hypochlorous acid is formed. Even bleaching powder also, hypochlorous acid is formed. So, here, the whole disinfection process, it is causing because of hypochlorous acid. So, this process, it is also called as hypochlorination. Okay, another name is hypochlorination. So, if I use this bleaching powder, there are some drawbacks, like I have to add particular or specific amount of bleaching powder to water. If I add more amount of bleaching powder which is than required to water, some unpleasant odor and taste will be attained to the water, which we as humans, we cannot drink that water because of that unpleasant taste and smell. So, in order to calculate how much amount of chlorine must be added for this disinfection, there is a graph proposed by the scientists. This graph is called this is nothing but the break point of chlorine. Okay, break point of chlorine, it is nothing but the calculated amount of chlorine that must be added to water for proper disinfection is called the break point of chlorine. Break point of chlorine, it is nothing but the how much amount of chlorine must be added. So, it can be better explained by taking this graph. If you see this graph, the x-axis, it contains the amount of chlorine. It is applied chlorine, nothing but amount of chlorine added. Okay, that is in grams. X-axis, it is nothing but the amount of chlorine that is added. And y-axis represents the residual chlorine. Residual chlorine, it is not preferred for drinking water. If residual chlorine is present, generally it is not preferred. Okay, so x-axis, it represents the amount of chlorine or the applied chlorine, and y-axis, it represents the residual chlorine. If you see this graph, it can be divided into 4 parts. 1, 2, 3 and 4. For example, I have I have added A grams of chlorine. When I have added this A grams of chlorine to water, all the reducing impurities, they will be oxidized. Means when I add A grams of chlorine, some impurities I am removing. I am removing some impurities. Now, if I add B grams of chlorine, to water, there will be formation of chloramines. Chloramines, there will be, if chloramines are there in water, or chloramine formation takes place in water, hypochlorous acid is formed. So hypochlorous acid, it will act on bacteria and it will kill. So when I add B grams of chlorine, this is a B grams of chlorine, chloramines formation will take place. Means bacteria, it will be killed to some extent. Now if I add C grams of chlorine, means all the bacteria that is present in water, that will be killed completely. Means disinfection process, it will be fulfilled properly and completely if I add this C grams of chlorine. Now I have not stopped adding chlorine at C grams. Still I have added D grams of chlorine. When I have added D grams of chlorine, this residual chlorine formation will take place. From this point, see in the graph also, the residual chlorine level, it is being increased. It is okay, it is to that extent, it is fine. But after this point, it is getting increased. Means residual chlorine, it is not preferred. And when I add D grams of chlorine, the residual chlorine, it is getting increased. Means for proper disinfection, I should add C grams of chlorine. Till this much amount of chlorine only I should add. So this C grams of chlorine, it is called the break point of chlorine. This is all about the graph of break point of chlorine, which is very important. That is, the graph, it is divided into 4 parts, namely A, B, C and D. A grams, it will remove the reducing impurities. B grams, it will result in formation of chloramines. The C grams of chlorine, it will the complete disinfection process can be done. Properly, the harmful microorganisms can be removed. D grams of chlorine, it will result in formation of residual chlorine, which is not preferred or which is not desirable. So, the C grams of chlorine, it is a break point of chlorine which will help us to decide how much amount of chlorine must be added for the water to perform the process of disinfection. Now, the advantages of the break point of chlorine is it will remove the bad taste, color and oxidizes organic compounds. Means if I add more amount of chlorine, obviously that bad taste and bad odor can be seen. So this break point of chlorine will help me to decide how much amount of chlorine I should add to water, so that the water, it doesn't attain any bad taste or bad smell. Okay. Now the second is 100% destruction of bacteria can take place. Means I can kill all the bacteria to 100% without leaving any single harmful causing microorganism in the water. Now it also prevents the growth of weeds in water. Means the chlorination, it will also help us in preventing the growth of weeds in water. Weeds in the sense the green particle growth you can observe in water. If it is staying for longer times, that weed growth can be seen. So if the water, it is treated with chlorination and it is stored for several days, that weed formation will not take place. If it is treated with chlorination, that is a chlorine gas or whatever the bleaching powder or chloramines, whatever we use, that weed growth will not take place. By mistake, I have added more amount of chlorine to water. Now that water, it can be reversed. Means the water affects that are caused because of adding over or more amount of chlorine to water, it can be reversed by passing the water through a bed of granular carbon. By mistake, if I have added more amount of chlorine, that is more grams of chlorine above break point, then that water is allowed to pass through a granular bed of carbon. Then that extra water chlorine is present, it will be removed, or that bad odor and taste, it will be absorbed by the carbon itself, that carbon bed. And another method is by addition of sulfur dioxide and sodium thiosulfate. By adding this sulfur dioxide and sodium thiosulfate also, that extra chlorine, what all effects that are caused because of adding more amount of chlorine to water, that effect can be eliminated. Okay, this is all about the municipal treatment of water. Talking about a brief recap. First, the water, it is collected from the source. Obvious here, though it is not there, screening and aeration process is done. Screening, aeration and sedimentation process is done. Screening, we will remove the floating particles. Aeration, air is bubbled through water, and it will, by bubbling, there will be increase in oxygen level, and also the dissolved gases like hydrogen sulfide, they can be removed along with the heavy metals like manganese and iron. So, after screening and aeration, it is subjected to sedimentation. Sedimentation means it is nothing but the water is allowed to stand for few hours, and the suspended particles, they will settle at the bottom of the tank and they can be discarded. Next comes the coagulation. Coagulation means we will be adding coagulants like alum, which will result in formation of gelatinous substances. These gelatinous substances will entrap the colloidal particles that are present in water, and once the colloidal particles get trapped in the gelatinous substances, it is subjected to sedimentation. In this sedimentation, the water is kept undisturbed. So again, those gels which will entrap the colloidal particles will settle at the bottom of the tank, and they can be removed easily. Now, after sedimentation, the water is allowed to pass through sand filters. That is, a filtration process is performed. In this filtration process, we are using the slow sand filters and rapid sand filters. These sand filters, they will contain several layers where the size will be differing. That is a quartz gravel, fine gravel, quartz sand and fine sand. In this filtration process, whatever the leftover colloidal and suspended particles are there, they can be removed. And the fine sand layer, that must be scrapped off to maintain the rate of filtration. Okay, after this filtration, it is subjected to disinfection. Okay, disinfection process is followed where the water, several methods of disinfections are there, like boiling, ozone treatment and chlorination. Boiling and ozone treatment, they are not preferable for municipal water supply. Boiling water, it is used for our household purposes because we will be boiling only smaller quantities of water. Boiling, it is applicable only for smaller quantities. And then ozone treatment, it is very costly, that's why it is not preferred. Ozone treatment, it is preferred for pharma industries, means sterile water, for production of sterile water. So finally, the municipal water treatment, chlorination is preferred, that too with the help of bleaching powder. Chlorination, it can be 3 reagents can be used, that is a chlorine gas, chloramines and bleaching powder can be used. Among all these 3, bleaching powder is preferred for municipal water treatment. Once the disinfection is done, it is set for the storage, that is a overhead tanks will be there. The water is stored in that, and daily it is distributed for our houses. These all processes will be, this is a overhead tank. So, for the water to reach our home, it is subjected to several stages of treatment, like coagulation, sedimentation, filtration, disinfection. All these steps will be there where the water is treated properly, and once it is treated, it is tested whether it meets the characteristic properties of the potable water. Once all that process is done, then only it is supplied for our houses for domestic purposes or for drinking purposes. This is all about the treatment of water. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.